All right, last lesson for Unit 4, intermolecular forces. All right, that word, inter, means between. All right, so this is how interactions between adjacent molecules. All right, so these aren't bonds. They're just attractions of neighboring molecules. And by the end of this lesson, you'll be able to talk about strengths and different types of these and when they apply. So, again, covalent compounds share their electrons. Sometimes the sharing is uneven. All right, so polarity, if you're dealing with a polar molecule or not, will have an impact on the intermolecular forces of neighboring molecules. So there are 3 major intermolecular forces, or IMFs, that you need to be familiar with. The first is your dispersion forces, right? Sometimes also called London dispersion forces. They are the weakest of all intermolecular attractions, and they occur between nonpolar molecules. So your molecules that have less than a 0.5 electronegativity difference. All right. So these are really, really weak, but they do help the neighboring molecules attract to each other. And if you can make the molecule get bigger, like longer, so there's more surface area to interact, these will actually get a little bit bigger. Dipole-dipole interactions are when you have polar molecules. All right, these are medium strength, but when you have a polar molecule, like say you have hydrogen and chlorine. Oops, come on. All right, chlorine has like a 0.9 greater electronegativity than hydrogen, which means the electrons that they're sharing are going to spend more of their time circling the chlorine. So chlorine will have a slightly negative charge, not a full negative, just a partial negative. That's what that symbol, it's actually, I think that's delta. All right, whereas hydrogen will have a slight positive charge, which means if you have a neighboring hydrogen and chlorine, all right, you're going to get a weak attraction between the negative chlorine end and the positive hydrogen end. All right, so that's a dipole-dipole interaction. Another example that you want to be familiar with is hydrogen bonding. These are special dipole-dipole interactions that are very, very strong because the difference between the electronegativity difference is a lot bigger. All right, so this will only occur with nitrogen, oxygen, and fluorine, and hydrogen. All right, so hydrogen bonding is what gives water its amazing abilities to, essentially make life possible for us. But, so hydrogen bonding is a misnomer. It's not a bond. It's still a partial positive, partial negative. All right, but it is considerably stronger than dipole-dipole interactions. So again, the negative end of a water molecule is attracted to the positive end of a neighboring one. All right, so dipole-dipole interactions are between polar molecules, but hydrogen bonding is reserved for those that have nitrogen and hydrogen attached to each other, oxygen and hydrogen attached to each other, or fluorine and hydrogen attached to each other. So, let's rank these in order of increasing strength. All right, so we're going to start with the weakest one and go to the strongest one. All right? If you start with these 3, and can get those in the right order, that's awesome. All right, so the weakest intermolecular force is your dispersion forces, and then it goes your dipole, and then it goes your hydrogen bonding. All right, and then the strongest interaction of all of these is actually your covalent bond. Bonds are always stronger than intermolecular forces. All right. These are IMFs, and IMFs are always weaker than bonds. Okay. So, here's another sort of question you might see. Which of the following explains why iodine, I2, is a solid at room temperature? All right, the key here is really this question is asking is which of these intermolecular forces applies to iodine? All right, well, iodine is two iodine molecules bonded together, all right, which means they're going to have equal electronegativities. So what was the IMF that associated things that were nonpolar? All right, your dispersion forces. All right, which of the following would have hydrogen bonds? So hydrogen bonds is in the intermolecular force. All right, so they have to have hydrogen, which all of these do have, but then the hydrogen has to be attached to either nitrogen, oxygen, or fluorine. Which means D is your correct answer. And one last thing to think about in relation to polarity and these intermolecular forces is, again, the greater the polarity difference, the stronger, if that polarity gets big enough, you're going to have dipole-dipole interactions, or if it graduates to the level of being a hydrogen bond, that higher that polarity is, the stronger the intermolecular forces will be, and therefore the higher the boiling point. All right, so looking at these, we've got hydrogen attached to everything in this column. So which of those would have the highest boiling point, aka which would have the strongest intermolecular forces? And that would be your H2O.